Once again, we're going to solve another quadratic equation. Make this look a little neater. Again, just like the previous example, we are going to clear all of the fractions. In this case, I have 3 fractions. Before you worry about what the common denominator is, make sure you have factored all the denominators. This is x minus 2, x plus 2, those don't factor at all, but this is a difference of squares. So if you would allow me, you can see my whiteboard is not super large. I'm just going to factor that difference of squares and write it right under this fraction right here. So I've got x plus 2 times x minus 2. In general, your common denominator, it shouldn't be too big of a deal to find. You just take one of every factor you see, and if there are powers, you take the highest power of the factor. So one of every factor you see, and then if there's powers. So I see I've got an x minus 2, I've got an x plus 2, I've got the same factors here, so that means my common denominator is going to be x minus 2 times x plus 2. So what I like to do is I like to write my common denominator next to every fraction, so that way I can do my canceling. So there's all of my x minus 2's and my x plus 2's, and now we're going to get rid of the fractions, and I should have an equation here that has absolutely no fractions in it. So when I do that, first one, my x minus 2's cancel, and I'm left with x times x plus 2. Don't forget to distribute, very common mistake. X times x is x squared, x times 2 is 2x. The second fraction, the x plus 2's cancel, and I have 1 times x minus 2, so that's just x minus 2. And on the other side, everything cancels, which is great. A nice canceling party that we have over here, and I'm just left with 8. This case, I've got a quadratic equation. So remember, whether you're going to factor or whether you're going to use the quadratic formula, you have to get the quadratic equation equal to 0. So I'm going to do 2 things here simultaneously. I am going to add my like terms. 2x plus x is 3x. Then I'm going to bring the 8 over by subtracting it. And when I have negative 2 and I subtract 8, that gives me negative 10. Now you are welcome to use the quadratic formula. It will always work. In this case, a would be 1, b would be 3, c would be negative 10. But I see that this is going to factor, and I think factoring's faster, so I'm going to go ahead and do that. So x squared, my firsts are going to be x and x. Then the 2 factors of negative 10 that are going to add up to positive 3 are going to be positive 5 and negative 2. If you need a review of factoring, I can provide you some videos to review factoring. Just send me an email, let me know. Principle of zero products, or just basically some middle school math, says that if I have 2 things multiplied together equal to 0, that either the first thing or the second thing has to be 0. So in this case, my first possible solution is negative 5. My second possible solution is 2. Now I say possible solution because both of these things indeed are solutions to the quadratic equation. But I have to take into account that I started with a rational equation. You have to make sure your answers are part of the domain. You might keep both of these answers. They might both work. They might both not work. One of them might and one of them might not. You've always got to check. So here we go. When I put negative 5 in, negative 5 minus 2 is negative 7. That's not 0. Negative 5 plus 2 is negative 3. That's not 0. And I have the same 2 factors here. So negative 5 works. It's great. When I put 2 in, 2 minus 2 right here, 2 minus 2 is 0. What that means is that the x value 2 is not in the domain of that function, so that is not a real answer. It's a fake answer. Sorry. And so that means my solution set is just going to contain the value negative 5. And we are done. That is how you solve a rational equation.